So today, once again, it is our last section. Today is on spheres, and the definition of a sphere is it's the set of all points in space that are equidistant from a given point. Now, the radius of a sphere makes sense because once we think about circles, I'm going to turn this circle into a sphere, sort of. I'm going to try my best. There, now it looks somewhat three-dimensional. Okay, so the radius of a sphere is just like the radius of a circle. It goes from the center of a sphere to a point on the sphere. So there's our radius.
Would it not just be to the dotted line?
It could be. There are an infinite number of radii in a sphere. I just drew it to that point instead of over. I certainly could have. Okay, a chord of a sphere is a segment whose endpoints are on the sphere, so we can have a chord anywhere. It doesn't have to be across. It could be here, as long as it just, here we go, we'll draw one. From this point to this point. There we go, chord. And a diameter is a chord that contains the center. So the diameter would go all the way across through the center. There's the diameter. So a chord just connects any 2 points. We don't do much with the chord here. We can use the diameter, but mainly just to give us the radius.
Can the chord be arc on the outside?
Can the chord be what now?
Be an arc on the outside? Or is it like
No,
straight line?
it goes through. It is a segment. Okay, now, does anybody know the word great circle?
Circle that is great.
It is. It is the greatest circle. It's the intersection of the sphere and a plane passing through the center. So it's the intersection of the sphere and a plane passing through the center. And because we're passing through the center, a great circle is actually the largest circle that can be sliced from a sphere. Does that make sense? Hence the word great. Okay, the circumference of a great circle is the same as the circumference of the sphere. So the circumference of a great circle is equal to the circumference of the sphere.
What does C mean?
Circumference. All right, what do you guys think a hemisphere is? Half a sphere. Okay, so those are all of our definitions. And now we're going to see how we can apply the mathematics. Okay, sometimes my spheres look better than others. Okay, so here we have a sphere. We'll draw the radius that way this time. And let's say the radius is 2 meters. There are 2 things we can find for a sphere: surface area and volume. The formula for surface area is 4 pi r squared. And the formula for volume is 4/3 pi r cubed. So if we were doing the volume of a hemisphere instead of a sphere, what would the volume be? Instead of 4/3, 2/3, half of that. Great. All right, so given this first example, what is this exact surface So exact. Exact tells us what will we have in our answer?
16 pi.
The pi. So this gives us 4 times 4, or 16 pi meters squared. Now, this is our exact. What is our approximate surface area? So then we would just punch that in our calculator. And 16 pi is approximately 50.27 square meters. Okay, so surface area would be like, if this were a tennis ball, it'd be an extremely large one. A tennis ball with a radius of 2 meters would be huge. That's about the size I need to be able to hit. But anyway, surface area, if you were asked to find how much material would we need to cover the tennis ball, that would be a surface area question. Okay? Material for the outside. Now volume would be how much can we fill the inside? What would it take to fill the inside? So the volume, how much space does it take up? So it would be 4/3 pi times my radius cubed. So the exact answer would be 32/3 pi.
Do you always put the pi out to the side and go on?
It can certainly go up in the numerator. So pi can either go out to the side or in the numerator for a proper answer. Okay, and the decimal approximation for that, did you guys get 33.51 cubic meters?
Yes.
Great. Okay, so that's just basic, finding the surface area, finding the volume. What we're going to do is go in between things. So I might tell you that the surface area of a sphere is approximately 10 square centimeters. Find the volume. Hey, think about those two formulas. What parameter do they have in common? Radius. So that's what we'd have to solve for to go in between the two. We would have to solve for the radius. So surface area, we know that surface area for a sphere is 4 pi r squared. And we'll just solve for r. So here we take 10, divide it by, make sure you put in parentheses the 4 and the pi if you do them together. So we get r squared is approximately 0.7958. Just leave that number in your calculator and then do square root of the answer. And did you get the radius is approximately 0.89 centimeters. Does everyone see how to get that answer? All right, so now to find the volume, just leave that number in your calculator and go ahead and cube it, because that's what we're going to have to do with the radius. Leave it in your calculator. Don't re-enter it. Go ahead and do that number raised to the 3rd power. And then times pi times 4/3. And did you get that the volume is approximately 2.97 cubic centimeters.
Not 0.95.
Okay, did you leave all your numbers in your calculator, or did you enter this for your radius?
Sorry.
That's okay. That's okay. They're really close, but if you just always leave it in the calculator and deal with that and don't really truly round to the end, you'll get a more accurate answer. And as you're always wondering, if you wrote 2.95 on your test, I would not count off. If you have work supporting that answer. Okay. You might also have something like this. The circumference of the great circle is 8 pi. Find the surface area of the circle. It's not a circle. Sphere. There we go.
Do you want exact and approximate?
Let's do both. Let's do both exact and approximate.
Do you have to put units if you don't get any?
Since I did not give you any units, what you would write right here is 64 pi square units. And so the approximate answer would be 201.06 square units. Are we ready?
We have to get 4 as the radius. So once you divide the 8 by 2 times, it'll just do.
You got it. What happened? Any other questions about this one? Alright. Let's do a made-up word problem here. Let's say you have a wooden ball.
Do we have to write this down?
No. You have a wooden ball that you're going to cut in half. And paint. So, you want to know the surface area of half the ball. So you know how much paint's by.
So instead of the number 4, you do 2.
Okay? So let's think about this. Surface area would be half, so you're right. So surface area for a hemisphere would be 2 pi r squared, because we're not doing the whole sphere, we're just doing half. Now, if I take this ball and cut it in half, and I want to paint the whole thing,
You have to find the circle too.
you have to find the base, don't you? Which is a circle. So, we do this plus the base. And the base is a circle. How do we find the area of the circle? Pi r squared. So do you see, for this particular problem, it ends up being 3 pi r squared. So we had 2 pi r squareds plus 1 more pi r squared. That's 3 pi r squareds. Okay, so when we have a word problem such as this, you have to think, will I include that great circle or not? Is it part of my answer or is it not? In this case, it would be. Sometimes it's not. Like if I were to build a structure that was a hemisphere, would I paint the ground?
No.
No. So you just have to think about the word problem you're given and ask yourself, is it included or is it not? All right, that's all I want to do with you. We don't have to actually do it. I just wanted you to start thinking. All right, I'm going to give you class time once again to start this assignment. It's on page 239. We're doing 1 through 9, 11, 12, 15 through 18, 20, 22, and 24 through 26. We will go over these tomorrow as well as the review from last night.